Alrighty. Good evening to everyone. Right. Do we have any questions concerning any of the modules? I mean, any of the units we have covered so far? Right. Be it relative velocity, resulting, or projectile motion.
Uh, so, is it possible that we can go over projectile?
Have you watched the video on projectile motion?
I asked for a link, I think during the week or so on the projectile motion, but I didn't watch any videos yet, so.
Right. Let me send a video on projectiles first, because there is a video on projectiles on my channel. Right. Also, that video is available on Moodle. Or are you not on Moodle? Hello.
I am on Moodle, yes, sir, but how do you call it? My internet connection, I struggle with it now, so I'm using the textbook rather than Moodle.
I see. But first, just watch the video, and then if you're still struggling, right after this session, I'm also going to send you some worked exercises on projectile motion. Right. When we do a live session, I want people to have gone through the content first, so it won't be like I'm teaching the unit. Right. During our live sessions, I just want to address problems, right, or maybe any misconceptions. Right. Otherwise, our sessions, right, will stretch further than they have to. All right. So again, any questions regarding relative velocity, resulting, or projectiles?
I have a question, sir.
Yes.
Okay, in the textbook, if we go to page 14 in the textbook,
Textbook. Page 14.
yes.
Right.
So so fine. If you just go to the previous page, yeah, example 1.6, they say there, they give you all the statement, right?
Mm-hmm.
Fine. And then there's the question, right?
Mm-hmm.
Fine, fine. Okay, fine. Blah 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 blah. Okay, fine. So number B, right?
Okay. P velocity of a
Number
relative.
B. For number B, yes. For number B, on figure 1.17, right? Can you just explain why they placed theta why they placed theta where they placed it? On figure 1.17.
There is no specific reason. They could have placed it there, or they could have placed it just below that. Right. So the theta
Now
is
the
placed
thing
there.
is, right?
So the
Oh,
the theta
so
is placed there to show you that the angle that they calculated is reference from the y-axis. That is what it means essentially.
okay. The thing is, right? when they place the theta there, like they did in the figure, right?
Mhm.
It changes that tan equals y over x. It gives it a different value.
It doesn't give it a different value. It's just that now theta you have to calculate differently. By differently, I mean uh, there's something like this there. And theta is here, right?
Mm,
So here you have the sum of v a b in the x in that direction, right? Headed
yes.
west, and then headed north. You have the sum of v a b in the y direction,
Mm,
right? And then here you have v a b, right? So now when you calculate
yes.
theta, remember tan theta
Mm,
is opposites over adjacent. So the opposite
yes.
side that's opposite the angle is this one now.
Mm,
Meaning
yes.
that you have sum of VAB in the x direction divided by the sum of VAB in the y direction. Right?
Yes.
Whereas had they calculated beta instead,
Yeah.
right? Then this would be tan theta is equal to, now the opposite side will be this one, which is equivalent to that.
Yeah.
So your numerator would be sum of VAB in the y direction divided by the sum of VAB in the x direction. If you were looking for
Yeah.
the angle, the opposite side would be this one, which is equivalent to that, hence your numerator. Right? The denominator must be the side that is adjacent to the angle, and this side is equivalent to that one.
Okay.
Yes.
So what I was saying like is that the question, right? Have gone with beta and not theta, because theta is the one that makes sense with everything else they gave. But then instead they went with theta, and I'm saying no, they should have gone with beta.
Doesn't matter.
Okay, doesn't matter.
Doesn't matter. Because if you look at the question didn't specify if your angle must be referenced from the y-axis or x-axis.
Okay. Oh, okay. No,
Doesn't
I
matter.
see, sir. I see.
Right. The way I've taught you is that if you're using the method of components, I prefer, right, it is preferable that you reference your angle from the x-axis. That way, even when resolving an oblique vector into its components, right,
Yes.
you make use of the angle that is referenced from the x-axis. That way, your the horizontal component, right, will always be in terms of cos, and the vertical component will always be in terms of sine, right? That is so that you don't confuse um, having to reference your angle from the y-axis and then still using cos for the horizontal component and sine for the vertical component. So it's to avoid that confusion.
Okay.
Otherwise, it doesn't matter. Right? Mathematically, you're going to get the same thing. Because even with this one, uh, even with this one, they got 21 degrees for theta, 21,739, right, degrees for theta. The theta is referenced from the y-axis, hence they got west of north. West of north is the same as north, 21,739 degrees west.
Hmm.
Now, had you calculated beta, right, right, the most important thing here is that the x component is headed west, the y component is headed north. So even if you calculated beta, the only difference is that instead of west of north, you would have west the angle beta north. That's the only difference.
All right, sir.
That's right. Otherwise, it still gives you this direction.
Okay.
Are you satisfied?
I'm satisfied. Thank you, sir.
All right. Next question. Are people not asking questions?
I have another question, but I'll wait until someone else raises their hand.
If someone is raising their hand, they must just say something.
Also, I was raising my hand because the one student, she's requesting to join the meeting, but no one is letting her in.
Letting her in. The group
Yes,
does-
to join the meeting, so
But this thing doesn't need permissions. Meeting options. Yeah, everyone can bypass. In fact, I don't know. I don't even see any request here. So I have no
sorry, I
idea
think
how-
she has the wrong link.
Second,
I think she has the wrong link.
perhaps. Can someone just resend the link in the group? Right. Otherwise, let's forget about them for now. So my question was: are people not asking questions because they are really that comfortable with relative velocity, resulting velocity, and projectiles, or what's going on here?
I think I'm one of the few who aren't comfortable, sir.
Well, at least you're asking questions. What's your next question?
And so,
Yes.
my thing is, I've been working through past papers now since last week, and I
Okay.
thought that I understood the module. But what is happening is when I'm working through the past papers, and I say now I use my X as reference, and then when I go to the memo, when I'm done with the question paper, I go through the memo, then I see they would use the Y axis. So that is where I'm still struggling, so to decide which axis to use. If you can maybe assist me with that, please.
It doesn't matter, Chief. If in the memo, even my memos, right, the ones I send you, if you have referenced the angle from the x-axis and I have referenced it from the y-axis, all you do is you just take your angle, subtract it from 90 degrees, and you should get the same thing.
Okay, so and I also went through one of the videos this morning. I did go through it last week, but then I went through it again just to pick up like why they always use the x-axis. But then I noticed you said when you it's almost like when you use the y-axis, then you must use cos for the y and sine for the x. But when you use x as the reference, then you can use cos for the x-axis, and then
Yeah.
y for the sine for the y-axis. So that's what I noticed is. So
Yes,
it's a bit
exactly.
clearer now.
Yeah.
Okay,
That's the
thank you,
only
sir.
reason why. Right. That's the only reason why I emphasize on referencing your angles from the x-axis, because most of you um, tend to confuse how you write down your components if you have referenced your angle from the y-axis. Right. For instance, if the angle is referenced from the x-axis, then the x component will always be in terms of cos theta, and the y component will be in terms of sine, right? But this only happens if the angle you are using is referenced from the x-axis, right? Once the angle is referenced from the y-axis, right? So the angle changes. Let's call it beta, right? If the angle is referenced from the y-axis, then this is actually the other way around. So this will be that angle, right? So when the angle you are using is referenced from the y-axis, then the x component will be in terms of sine, and the y component will be in terms of cos. So to avoid this confusion, because some of you tend to think that the x component is always or is in terms of cos, and the y component is in terms of sine, regardless of the angle, which is incorrect. So to avoid that confusion, that is why I emphasize on you guys referencing your angles from the x-axis to avoid that confusion. I don't know if I'm making sense here.
Yes, sir. I understand now. Actually, since this morning.
Okay.
And so my other question is, I've asked this question in the group as well, but then one of the students, they replied, for assessment one, must we only expect the one module, or can we expect general questions as well, so for the assessment?
What do you mean general questions?
Because some of the past papers that I worked through, they would use general questions for question one and so on. So
You mean exam questions?
yes.
Oh, now for your first assessment, it's only kinematics.
Okay, thank you, sir.
So everything that has to do with kinematics, relative velocity, resulting, projectiles. Only module one. All right, so only module one. All right, any more questions? Someone had a question.
Yes, sir.
Uh-huh.
Yes, sir. Can we please do example 1.14 in the textbook from scratch?
Okay, let me see the example. On what page is it?
It's on page 24.
Projectiles. The cannon situated. Okay. We can do this one perhaps on our next session, because some of you haven't even watched the video on projectiles.
Or did you post it on the group to your YouTube channel, sir?
It is on my channel. I'm not sure if I posted the link in the group. So perhaps I can send the link to the group, but the guys that have access to Moodle, right, it is there.
Oh, so what are we going to do up to in this session?
Resulting and relative velocity.
Oh, okay.
I wasn't even aware that people hadn't watched the video on projectiles, right? But since I am aware of that now, I would like people to go through that video, right?
So I have a bit of a background on the projectiles because I
Okay.
did entry last trimester. So I don't think that it will be a problem if you go over it in the session. So because the thing where I'm not like on, how can I say, can't quite understand yet is the how to work out the angle and that type of stuff. So, but the like how can I say which the other stuff. So I'm okay with actives. It's just the angle that I'm struggling with. So if you would like to go over it, so that's fine by me. I don't know about the other guys.
Right. So the reason why I'm insisting on not going over it is because I don't like going over a module. So going over a module means that people have actually done the work and there's some confusion somewhere. There's some misinterpretation of the information, either information that's on the video or information I sent, um, either via the group or in an exercise that I've worked out. Right.
Okay, so
I want people to have a good idea of the units or of the module before the live session.
so when will the next session be? So
That will be up to you. If you go through Project House today, we can go through it
yes,
even.
tomorrow.
Yes, we can go through it even tomorrow.
Yes, that will work. Yes, so but then you must just give us a time and stick to that time, please.
The time will be 6. It would have to be 6 p.m. Tomorrow is a public holiday. We can make it 11 a.m. tomorrow. Right, as long as though people have actually done the work. Right, so you watch the video and attempt a couple of exercises.
Hi, sir.
Yes.
Hello. Yes. So I I read the example and I tried the exercises, right?
Mm-hmm.
Like I tried everything. Like I really attempted it, right? But there's a lot of stuff that doesn't make sense. So I did have a really proper try, a really proper attempt at that type of work with the cannonball that just starts off at like it doesn't like, how can I say, it doesn't go up vertically. It just
Mm.
starts already at velocity zero and then it starts falling due to gravity. So that
Yeah.
really confused me. So that's why I want to see your technique. Um, and yeah, I can go watch the video, but here you are right now. So I think that's also fine.
Right. But like I'm saying, if I do it now, it will be like I am teaching you guys. I do not want to teach people.
It's not teaching. So I think the textbook did a very bad job at explaining it. So I just want to see your technique in doing it because I tried everything and it didn't make sense.
You
It just really didn't make sense.
you didn't try everything because you haven't seen my
No.
technique.
Okay.
That's my point. You haven't watched my video. So if I go through this,
Oh,
right, without you having watched the content, I'll essentially be teaching you, which is going to take
is it
way more time than me having to explain something that you've already went through using my content.
oh
Yes.
is it possible, sir, for someone to go through this subject with only the textbook, or must they also watch your videos?
You definitely need to watch videos. Um,
Oh,
Engineering science, you cannot just simply use the textbook because a lot of the content has to be explained.
oh, I see, sir. Okay. Oh, well, let me find something to do with
Even
resultant
if
velocity then, since we can't do projectiles.
even if it's not my videos, any kind of content that you can get that's helpful on YouTube or from any other students or other lecturers, right? You definitely cannot do the subjects on your own.
Mm,
Yeah.
yeah. Because I noticed even the textbook has a lot of mistakes.
Mm, okay, I cannot say much about that. I don't use the textbook too much.
Oh, okay.
Yeah.
Okay, no, I see, sir. Okay, well, I'm on my end. I'm just gonna now find my other questions to do with either relative or resultant velocity. Then I'm gonna do that, sir, on my end right now.
Okay.
Because I've got some other things I want to raise to you, but they just uh they're a bit further away. Let me just quickly find them.
Okay.
Yeah.
Anyone else has a comment, question? Hello. So everyone else here, I guess, is fine. You guys don't have any questions? Is it because of the problems or the exercises that you have done? Everything was fine, hence you don't have any questions, or what's the story?
Hi, sir. I don't know about others. I'm sure they also have some stuff to ask, but on my end, there's a lot of things to ask. I'm just separating all the things that have to do with projectiles and only just trying to find the things that have to do with relative and resultant velocity. Just a few minutes on my side, sir.
All right. Also, it is important that you, right, in doing exercises, that you make sure you visit past exam questions. If you look at the tutorials I've uploaded on Moodle and the ones I send in the group, those are from past exam papers. It's the exercises on the textbook for the most part are not one that are challenging or that are on the standard of assessments. Right, that is why you need to familiarize yourselves with past exam questions so that you get an understanding as to the format or the kind of questions you can expect in assessments. For instance, I never use the textbook for setting up assessments ever. Right, the textbook
Hi,
is
sir.
there perhaps for you guys to get an understanding. Otherwise, as far as competitive questions, those you are going to find in past exam questions. Yes.
Yes, sir. Can we please go to the 27 November 2023 past paper?
27 November.
Yes.
27 November 2023.
Yes.
Okay. 27 November. Okay, let me just look here quickly. 27 November. Yes. $2023.
Yes, sir.
What is this? I think this is August. Okay, I don't have this thing here.
You can check in the group also. I just sent it now.
Mm, November. Let me see. Wait. I'm just want to check the one I have here. This is August 2024. November 2023. Yeah.
Okay.
Right. Which
Can we
question?
please do 1.2, 1.3, and 1.4?
Point two. A scooter is what is the relative velocity? One point three. One point four. 1.4 is projectile. We can do it tomorrow after you guys
Okay.
went through the video.
So just 1.3 then, sir.
In fact, that 1.4. 1. 1.2 is relative. Right, a scooter is moving at 120 kilometers per hour in the direction south 40 degrees east. The car is moving at a velocity of 100 kilometers per hour to the east. Right, what is the relative velocity of the car with respect to the scooter? Right, first things first. Right, we are going to draw or represent the vectors on the Cartesian plane. Right, doing so requires that you identify, right, which of the two objects you are going to take as the object and which one we are going to take as the frame of reference. Now the question here is, what is the relative velocity of the car with respect to the scooter? So between the car and the scooter, which of those is the object?
The car, sir.
Right. So the car is the object, meaning that the scooter is the frame of reference. So the car here we are going to draw in the same direction as the one we've been given. They say a car is moving at this east. So we are going to draw the vector of the car headed east. Right, east is in that direction. right? Now we look at our frame of reference. Our frame of reference is the scooter. The scooter is moving at 120 in the direction south, 40 degrees east. Right now, because the scooter is our frame of reference, the frame of reference here you draw in a direction that is opposite the one you've been given. Right, opposite of south is north. The angle remains the same. Opposite of east is west. Right. So meaning that here we are going to draw a small Cartesian plane. Right, on that end, and this is headed north 40 degrees west. North 40 degrees west is on the second quadrant. So on this small Cartesian plane, right, that's the first, that's the second, that's the third, that's the fourth. So northwest is in the second quadrant. So meaning that this is somewhere here. Right, this is 120, that's 100. Right, this is somewhere here.
Excuse me, sir. Can I just ask a question quickly?
Yes.
That method that you showed us last week, can we not apply that with this equation? Where we draw the information as given and then just add the result and then work it out like that.
At the results and work it out like that. I'm lost. Just say that again.
You remember the method that you showed us last week where we draw all the information on the plane as given and then just attach it 2 points to calculate the result. And or am I now wrong now? That method you showed us last week.
The method I showed you last week.
Where you draw the information as given in the question and not change direction.
We can do both.
Oh, okay.
We can do both. Okay. So if we're doing that, okay, let's do this then. If you are using the information as given, so if you're using the information as given, this would be in this quadrant.
But then we just use the direction of the scooter as relative to the x-axis and not that south 40 degrees east.
So if it is referenced, if the angle is referenced from the x-axis, this would be east. And what would the angle?
60 degrees south.
Can't be 60.
50, sorry, 50.
Yes. 50 south. If that's the case, still here. Now the angle we are using is the 50 degrees. So that's in that direction. So here you have the 120. So this vector is 120. And then this one is 100. So we can say, so using this, we'll be using the method of components. So we can call this the velocity of the car. Velocity of the car in the x direction, which is positive 100. Right, and then obviously this one, because it's an oblique vector, we have to resolve in its components. All right, you need to resolve this one to its components. Right. So the horizontal component of this because it's headed east, is going to be positive 120 cos 50. And then the vertical component will be negative 120 because it's headed south, sine 50. Right, that is if you are using the directions exactly as they are. Right, the question is calculate the velocity of the car relative to the scooter. Right, now we apply conditions of equilibrium. Sum of V car relative to scooter in the x direction. Right, that will be the positive. So that will be, okay, I forgot to name this. This is equals to V of scooter in the x direction. And this is V of scooter in the y direction. Right. Now, as far as having to apply conditions of equilibrium, right, when you are using this approach, right, it's going to be V of car, so V of car in the x direction minus V of scooter in the x direction. And then you substitute. So this will be V of car, or 2x's here. V of car in the x direction. So this will be 100 minus the 120 cos 50. And what do you get here? What is 100?
I get 22,865
Positive.
kilometers per hour. Yes, sir.
22,
865.
865 kilometers per hour. Because it's positive and it's in the x direction, that means this is east. All right. Now we calculate the y component of the resultant sum of V car relative to scooter in the y direction. This will be V of car in the y direction minus V of scooter in the y direction. All right, so now obviously, because the car is traveling east, right, it means the vector is only parallel with the x-axis. So meaning that there is no component of the vector of the car in the y direction. So this, you take a 0 minus the negative 120 sine 50. And what is this equal to?
That's 91,925.
91, 925. Is it 91,925?
Yes, sir.
So positive, because it's positive and it's along the y-axis, it means this is headed north. Right? The two directions, right? When using the method of components, the two directions, right, allude as to in which quadrant your resultant velocity is going to be in. Right? So if you have north and east can only be in the first quadrant, meaning that what you are looking for will be in this quadrant. Right? Whatever the direction is going to be, or whatever the angle is going to be, right, it is going to be in this quadrant though. Right? These two directions allude to that. Right? Now you calculate what you're looking for, the velocity of the car relative to the scooter. Right? Now you apply Pythagoras. Right? Sum of V car relative to scooter in the x direction squared plus sum of V car relative to scooter in the y direction squared. All right, so now you substitute. Substituting, the x component is 22,865, yes, plus the 91,925 squared. All right, now what do you get here? What is this equal to? The square root of all of this, what is it equal to?
94,726.
94,726
Yes.
kilometers per hour. All right. Now, your angle, right? Because we've been using the method of components, let us reference our angle from the x-axis. So because our angle, the angle theta, because we are referencing it from the x-axis, it means the formula we're going to use is going to be the y component, so sum of v car relative to scooter in the y direction divided by the sum of v car relative to scooter in the x direction. It's essentially meaning that theta will be equal to arctan of this. All right. So theta is arctan of 91,925 divided by 22,865. And what you get is theta.
So you get 76,031, but I have a question on this, because in the memo they used the y-axis as a reference and not the x. So they used 10 arctan x
Y.
over y.
Yes.
And yes, sir, and we used y over x. So it's a
Yes.
totally different answer that we get according to the memo. Because when
Doesn't
I
matter.
did this question, I noticed it matters here, so because they only give you the point if you use the y as a reference and not the x.
Incorrect. Whether you reference your angle from x or y, as long as for both cases you are correct mathematically, you will get the marks for it. It doesn't matter if you reference your angles from x or y. Doesn't matter. Do you hear what I'm saying?
No, sir, I don't, sir, because in the memo they only give you the point
Okay.
for using the y.
Listen to me very carefully.
Okay.
I want you guys to listen to me very carefully. Right? I am fully aware of the marking process for engineering sites. Okay? Listen to me when I say it does not matter where you reference your angle from. As long as it is mathematically correct, you will get marks for it. Do you hear what I'm saying?
Okay, sir. Okay, sir.
Right? The memo you are referring to is not a standardized memo. Right? It wasn't standardized, meaning that memo was changed before marking took place. The memos you guys get on those apps, they are not accurate. They are not the memos we use. They are not standardized memos. They are not approved by DHET.
Oh, okay,
So
sir. Thank you.
the memo that was approved by DHET we consider both. You see what I'm saying? Or they consider both,
So
right?
what you're actually saying is when they mark it, then they have the answer for the y-axis and they have the answer for the
Exactly.
x.
There's always alternative
Okay,
answers.
sir. Thank you.
In fact, if you look at those memos, most of them, they don't account for all approaches, right? For instance, if you use the method of components, someone else could use the vector diagram. They do not, for the most part, account for all the approaches, right? In the standardized memo, they account for all approaches, right? Even if there's 3 approaches, then that means there's going to be 3 alternative answers. Are we together?
Together, sir.
Yeah. So again, it does not matter, right, where you reference your angle from. Right. So what did you get here? 76 comma?
Comma 032.
032 degrees. Now, remember that this angle is referenced from which set of axes? Hello? The angle we just calculated.
It's from the x-axis.
From the x-axis, right? Now, because the angle we calculated is referenced from the x-axis, right? It means the direction, right? The direction of our resultant velocity. So velocity of the car relative to the scooter magnitude is 94,726 kilometers per hour. Now the direction, right? Yes, exactly. The direction, because our angle is referenced from the x-axis, and as far as the x component, it is headed east, right? We then say here the direction is east. The angle is 76,032 degrees, right? And then the y-axis are north. So here you have north, right? Now, had you referenced your angle from the y-axis, right, you would have VC of scooter 94,726 kilometers per hour, right? Now, what is 90 minus 76,032? Hello, people. What is 90 minus 76,032?
It's 13.968.
68 degrees, right? Now, if you reference your angle from the y-axis, this is what you're supposed to get, right? And because this angle is referenced from the y-axis, your angle or your direction will be north, 13,968 degrees east.
Excuse me, sir. We can also must use that octane vertical component over the horizontal component, but just turn it around, eh? Like then it's the horizontal component over the vertical component.
Yes, if you reference your angle from the y-axis.
From the y-axis.
Yes. So if that is what you did, then this is what you would have: sum of v car scooter x divided by sum of v car scooter y. Right. So if you do this, right, if the numerator is the x component and the denominator is the y component, it means the angle theta is a reference from the y-axis. And if you did this, this is what you get: 13,968 degrees, more or less. Right? Are we? Is that making sense?
Yes, sir.
Yes, sir.
right? But again, does not matter where you reference your angles from. It's the x-axis or the y-axis, because essentially, whether you reference your angle from the x-axis or y-axis, it tells the same story, right? Because it means this is somewhere here, right? Probably much closer to this, right? Practically speaking, it'll be somewhere here. So this is the velocity of the car relative to the scooter, right? So whether the angle you calculated is referenced from the x-axis or the y-axis, right? They will give you the same direction. They will tell the same story. That is why it doesn't matter where you reference your angle from. Am I making sense here? Hello.
Yes, sir.
Hi.
Understand.
All right. Let us look at the other approach, the vector diagram. All right. Let's take the vector diagram approach. So this was the method of components. All right. Now let us use the vector diagram. All right. Now also note here that this you do if your vectors are in the same directions as the ones that have been given. Right. This approach you take if you have used the same directions as the one that you've been given, right, for both your vectors. So both the objects and a frame of reference. But if the approach you took is such that you draw the objects in the same direction as given, but the frame of reference in a direction that is opposite to what you've been given, then this here will be plus, not minus. But that is what I was emphasizing on when I was speaking about this approach. All right, now let us look at the vector diagram. All right, vector diagram. All right, the car is still obviously the object. The scooter is the frame of reference. So the object, which is the car, we are going to draw in the same direction that we've been given. So that's headed east. So we say that's headed east. All right. Now, frame of reference, we are now going to draw in a direction that is opposite the one that we've been given. All right. Opposite of south is north, 40 degrees. Opposite of east is west. All right. Right. Draw a small Cartesian plane there. Now this is north 40 degrees west, which is in the second quadrant. Right, so this meaningly is going to be somewhere here. Right, somewhere here, headed in that direction. Right, and then obviously you draw a line that connects the two vectors, and that line represents the
So we can't see anything that you're doing, sir.
second.
I can't see anything that you are currently doing, sir.
You can't hear anything that I'm currently saying.
That you are doing, that you are drawing on the what you call it.
The Cartesian plane.
Yes, can't see it.
You can't see it.
Can't see it, yes, sir.
Can you see this? Do you see the question paper?
Yep.
Right. How about now? Do you see the vector diagram?
I can see it now, yes.
Right. So what I said was the object you draw in the same direction that has been given, which is east. And then the scooter, because we've established that the scooter for this question is our frame of reference, you are going to draw the frame of reference in a direction that is opposite the one you've been given. So by opposite the one you've been given, the given direction is this one. So we are going to draw the scooter on the Cartesian plane in a direction that is opposite this one. Opposite of south is north. You keep the angle. Opposite of east is west. All right. Then you draw a small Cartesian plane here. Right, for you to be able to draw this vector. North 40 degrees west is in the second quadrant. Right, that is why I've drawn this. Right, relative to the small Cartesian plane in the second quadrant. All right. So this represents the object, which is the car, and this represents the scooter, which is our frame of reference. All right. So once you have drawn both, you then connect the two with a line, and that line represents the resultant. Making sure that, remember for the vector diagram, right, the object and frame of reference, they follow a head to tail direction. Right, they follow a head to tail direction. Right, but the resultant, or the line that represents the resultant, right, it must follow a direction that opposes head to tail. Right, hence this means that will be in that direction. And then this will represent the velocity of C, velocity of the car relative to the scooter. Right, the car is moving at 100, right, 100 kilometers per hour. The scooter is moving at 120 kilometers per hour. Right, so that's the scooter. Right, and then of course you have to work out your angles as well. Right, the only angle we have here is this one. Right, they said this is headed north 40 degrees west. So using this small Cartesian plane, right, we know that this angle is 40 degrees. Right, if that's 40 degrees, what is this angle equal to?
$50.
So that means, maybe we do this. This here is 50 degrees, right? And then of course you can name your vector diagram, call it A, call this B, call this C, meaning that's C, that's A, that's side B. Right? Now, if you look at the angle that we have here, right, it is between two known vectors, making it an included angle. Right? If you have the included angle, we are able to use the cosine rule. Right? So using the cosine rule, we are looking for the velocity of the car relative to the scooter. So the resultant here is A. So using the cosine rule, this will be A squared is equal to B squared plus C squared minus 2BC times cos A. Right? So A squared is equal to side B is 120 squared plus side C, which is 100 squared minus 2 into 120 into 100 times cos A. And the A is 50 degrees. All right. Now, what is A squared equal to? Give me the entire number. All right. This is equal to A squared. So punch this in your calculators and give me all the digits that you get. So do not round off to 3 decimal places. Give me everything.
So it's
A calculator.
8973.09, and then I rounded off me already before you spoke.
So don't round it off. Give me everything
Oh,
after the comma.
and then I don't know what I got because I wrote down and then I forgot and then yeah,
Okay,
but
It's
those are the
09
numbers that didn't round off.
09
0, 0, 7,
7
368.
368. Right. Now we are looking for A. Right. So you're gonna use the square root on both sides of the equation. So the square so now just press square root and answer and tell us what you get. Now this answer you can round off to 3 decimal places.
94,726.
Okay.
726 kilometers per hour. Right. Now we know that A represents what we are looking for. That's the velocity of the car relative to the scooter. Right. So we have the velocity of the car relative to the scooter, or the magnitude thereof. Right. Now we have to calculate the direction, or we have to determine that direction. Right. Determining that direction requires that you calculate the angle, either referencing it from the y-axis or the x-axis. Right. Based on our vector diagram, right, we'll be able to calculate this angle using the sine rule, right? And this angle is a reference from the x-axis, right? So you calculate B, calculating B using the sine rule. So sine B divided by side B is equal to, the angle we have is A, so sine A divided by side A, right? Now you obviously have to get rid of this B because essentially we're looking for the angle B. So we have to get rid of everything and be left with B on this side. So we first get rid of B by multiplying both sides by B. Multiplying both sides by B would get rid of the denominator B on the left hand side. Hence, you'll be left with sine B is equal to, and then this side you will have B, side B sine A divided by side A. All right. And then, of course, to get B, this is not beta, it's just B. To get angle B will be equal to arc sine of B sine A divided by side A. Right. Therefore, P will be, now you just substitute. Right. So now you just substitute. Side B is 120. Sine A, which is 50, divided by side A, which we just calculated. So this is 94,726. And what do you get here? What is this equal to?
76.033.
0.33 degrees. Right, we've already established that that angle is referenced from the x-axis, right? Meaning that now you can say, therefore, the velocity of the car relative to the scooter is 94,726 kilometers per hour. Direction, the angle is referenced from the x-axis. X-axis is east. Angle is 76,033 degrees north. Right. And then using the vector diagram, this is how you'd approach it. Right. Now, just to be clear, all of these steps, right, are for context. Right. Otherwise, if you were at a point where you knew exactly what you were doing, right, so this would still be the first step. Right. So this gives us context. Right, so make sure this is always the first step, right, when using the sine rule. But as far as the second step, right, you can simply go straight to here. Right, so you can actually have this as your second step. Right, and then of course you substitute, right, and find your answer. Right, I did all of this for context so that you see exactly where everything is coming from. Do I make myself clear here?
Yes, sir. Sir, if you can just check in the group, right? My solution, right, for the vector method, right? I took a picture of it, right? But then I got a wrong direction. Can you just quickly just glance there and show me where I went wrong? I can even highlight it for you in the group quickly, and then you can just tell me where I went wrong, because I got the same magnitude, right, for the relative velocity, right? But the direction was wrong.
Just resend it quickly.
Okay.
All right.
Can you see it's in the group?
Yes.
Yes.
I can see the magnitude. I don't see the direction though. Oh, okay. Okay, so I think I see where you went wrong here. You based your direction off of your schematic illustration.
Yes.
Yeah, that is where you went wrong. You were supposed to use the sine rule there. So had you used the sine rule would have told you that actually your vector diagram is wrong.
Mm.
Yes,
Okay. Sine rule, you say?
yes,
Because fine, I had 100, I had 120, I had 50 degrees, right?
yes.
So from those three, right, I can now find the other sides, right? I can find the other side and the other angles of that little triangle there, right? So now what was I supposed to do to get the proper direction um
Um,
for the relative velocity?
what I can say here is that never assume, right? Never assume that your resistance is parallel with any of the axes, unless you've been told.
Oh,
Never assume it though. So that helps.
okay.
Like for instance, this is what you have. Let me just draw what you have here quickly. Um, uh, so this is what you have. That's going in that direction. Then you have this. Okay. And you have this. Right. Now what I'm saying is never assume that your what is this thing that your resultant is parallel with either of the axes. Right. So you don't assume that it's parallel with the y-axis. You don't assume it's parallel with the x-axis. Right. So at worst, what you could have had here is this. You could have said rather have that instead.
Oh,
Right. Rather have that instead. Let me see. So for this to be accurate, let me see. Let me see. Let me see. So that's that. Yeah. Rather have this instead, or have it like this. You said this is going in that direction, which is correct. That's this one is like that. This one is like that. Yeah, this is what you have. And then as far as the Cartesian plane, right, this would be the Cartesian plane. Right. So I'm saying rather do it like this next time. That way you'll still have an angle to calculate, right? Be it this one or this one.
oh.
So you were
So,
going so you were going to calculate this angle, right? You are going to calculate that one,
mm,
right? Because um this is making an angle of here you have 50. So if that's 50, it means this is 50 as well. Yeah, you would calculate that angle, right? Either way, when you use
yes.
sine rule, the sine rule will tell you actually the resultant is on this side,
Mm,
right? It will tell you actually the resultant is on this side, right? This you will be told by the sine rule, right? The resultant is
mm,
actually this, right? But at that point, you won't need to redraw the vector diagram, right?
okay.
But the point is the schematic illustration, right? It helps to give you an idea as to what you expect, but the calculations right, the calculations will either confirm, right, or deny your assumption.
Understood, sir.
Yes. Right. So not to make the mistake of making readings your from your vector diagram, right? Make sure that your resultant is never parallel with the y-axis or x-axis. Never assume that. I don't know if it's clear.
We're clear, sir.
Right. Right. Any more questions? Right. Let us look at the second one. So this question is based on a resultant velocity. Right. The question is based on resultant velocity. Right. Now with resultant velocity, you must always look out for three vectors. Your original vector, the velocity of VW, which will either be the velocity of the wind or velocity of the water, depending on the scenario you're looking at. But if you're looking at an object that's moving through the air, then the VW will be the velocity of the wind. And then the third one is the resultant velocity. Right? Those, for resulting velocity, those are the three vectors that you have to look out for in your problem statement. Right? Now the statement reads as follows: a helicopter is flying at 220 kilometers per hour in a direction north 65 east, while a southeasterly wind is blowing at 45 kilometers per hour. That's pretty standard. Right, so this is a standard case of resulting velocity where you are given VO, you are given VW, and you are simply asked to calculate the resultant velocity. All right, so here we have VO, which is the original vector. All right, now this here can sometimes be referred to as the S speed, right, for a scenario where you're looking at an object that's moving via the air, right? If they've given it as S speed, or if you've been given S speed, right? S speed is essentially VO, or if you've been given the velocity of the aircraft relative to the air, or relative to the wind, or relative to still air, right? If they've given you any vector like that, just know they're referring to VO. All right, so VO here is the 220 kilometers per hour, direction north, 65 degrees east, right? While a southwesterly or a southeasterly wind is blowing at 45 kilometers per hour. So that is VW, the velocity of the wind. Now with the velocity of the wind, right, this only applies to the velocity of the wind. Right, you look at how the direction has been given. Right, you look at how the direction has been given. If they say, if how the direction has been given is from where the wind is coming from, right, then the direction you write down here will be the direction that is opposite the one you've been given. So the magnitude is 45 kilometers per hour, right? So if the direction that's been given is from a perspective of where the wind is coming from, so they would say while a wind that's coming from a southeasterly direction is blowing at this, for instance. If that's how the direction has been given, then you write down the direction that is opposite the one you've been given. Right?
Hello, sir.
For instance, if they say, all right,
Hi, sir.
north, yes, that's south.
Isn't that opposite rule only for what's it called? Relevant
Relative velocity.
relative velocity. Yeah. Isn't it opposite rule only for relative velocity?
Now, the guidelines.
No.
You have two different guidelines, right?
Yes.
The one for relative velocity, right? It applies for the frame of reference, right? For resultant velocity, there is no frame of reference, right? So the guidelines
For resultant velocity, there's no frame of reference.
no. There's no frame of reference, but it's something completely different, right?
Huh.
But now, I'm just highlighting the different ways in which that the wind direction can be given to you and how you interpret that wind direction.
Okay.
There's three ways in which they can give you the wind direction. They can either say the wind is coming from, or they can say the wind is going in that direction, or they do not specify if the wind is coming from or in that direction or going in that direction. So there's three ways in which they can give you wind direction. Right? They can either say the wind is coming from, or they can say it is going in that direction, or just like the one they do not specify whether the wind is coming from or going in that direction.
Oh, so like how did you learn all these things, sir? Like, did you use the textbook, or like how do you what's your basis of theory?
Being very good with vectors, Chief. Remember, I'm your tutor, but yeah, I'm a lecturer for the subject as well.
Oh, okay. You know, it confuses me, right?
Yeah.
Because you said that you can't just use the textbook alone.
Yeah.
I must also use your videos, right?
Yes.
Okay, fine. But then it's like, is this engineering science based off your videos or the textbook or both?
Both. See,
both.
In the textbook, they do not explain, like they don't give you like proper guidelines.
Oh.
This year, I definitely didn't take from the textbook. It's just me. It's based on my years of experience with vectors. Right? Not the resultant velocity or relative velocity, just vectors in general.
Sure. Okay.
That is why I said with engineering science, you won't survive trying to do it on your own, because there's a lot that needs to be explained there.
Okay. Well, I'm just gonna keep up, sir, with these very good techniques of yours, sir. You can continue.
Right. So, right, do not confuse resulting with relative velocity. We are looking at resulting velocity now. Right. The problem, right, this problem in particular is based on resultant velocity. Right? Like I said, there is a number of ways in which they can give you the wind direction. Right? They can say the wind is coming from the direction you've been given, or the wind is going in the direction that has been given, or they do not specify if the wind is coming from or going in the direction that's been given. Now, if the perspective of the direction that they've given you is based on where the wind is coming from, then you use the direction that is opposite what you've been given. For instance, if they say the wind is coming from a southeastern direction, so southeast is the same as south 45 degrees east. Right? If they say the wind is coming from that direction, right, it means the wind is coming from this direction. Hence, when you draw it here, right, if you draw it exactly as it's been given, right, this is how you would draw it. Right, it's headed in that direction, which is incorrect. Right, we do not draw vectors on the Cartesian plane coming towards the point of intersection. Right, the vectors must always be such that they are pointing away from the point of intersection. Right, so meaningly, right, drawing this, you would have to draw it pointing away in that direction. Hence, I'm saying if the wind direction has been given from the perspective of where it is coming from, you must draw it in a direction that is opposite what you are given. Right? Opposite of fourth quadrant is the second quadrant. Opposite of third quadrant is the first quadrant, and vice versa. Do you understand what I'm saying?
Understood, sir.
Right. So if the wind direction has been given to you from the perspective of where it is coming from, you write it here or you draw it here in a direction that is opposite the one you've been given. And then if the wind direction is given from a perspective of where it is headed, so in the direction that is headed, then you draw it exactly as it's been given. So for instance, they said here that this is blowing in a southeasterly direction. So in south 45 east, right? That would mean, right, in a southeasterly direction, that would mean it's going in that direction. That's in a southeastern direction, right? And it will be correct why it is going away from the point of intersection, right? And then the third perspective, which is the one we are looking at, is if they haven't specified if the wind is coming from or going in the given direction. If they haven't specified, just like in this case, they say while a southeasterly wind is blowing at 45 kilometers per hour, right? That doesn't allude as to if the wind is coming from or going in this direction. Right? So if the wind direction is somewhat ambiguous, right, you must take it as if it is coming from the direction you've been given. So meaningly, if it's coming from south 45 east, it means you must draw it here in a direction that is opposite this one, meaning opposite of south is north, right? Angle is the same, 45. Opposite of east is west, right? So they'll either say it's coming from or it's going in, or they do not say if it's going in or coming from. If they haven't specified if it's coming from or it's going in, then you must take it as if it is coming from the direction that has been given. Hence, when you write it here, you must write it or draw it on the Cartesian plane in a direction that is opposite the one you've been given. Are we together?
Put together.
Yes.
Right. So those are our vectors. So VR is missing, right? Having accumulated or having established which vectors you have and which ones are missing, right? This means that they are likely going to ask you to calculate this. And if you look at the question, calculate the resultant velocity in magnitude and direction, right? So here, just so we are clear, even if they just said calculate the resultant velocity, right, in magnitude, you also have to include direction. So when you calculate vectors for resulting velocity as well as relative velocity, you have to include direction. Right? They don't necessarily have to stipulate and direction. Right? Now let's show our vectors on the Cartesian plane. Right. Yeah, VO is northeast, so it's somewhere here. 220, somewhere here. 65 north, 65, so it's somewhere here. It's 65. Somewhere here, it's headed in that direction. Right. A small Cartesian plane here. And then VW is north, 45 west. That's the second quadrant. So this will be somewhere here. 45. It will be somewhere here. Right, that's VW. Right, once you have the two, simply draw a line that connects the two vectors, making sure that the direction does not follow head to tail. That means that direction. And this here will represent VR. So this is 45. This is also given, it's 220. Right. And then now you obviously have to work out.
Also,
Yes.
the blue line, right, for that 45 km per hour vector, right?
Mm.
It looks like to me like it's perpendicular to that 220 vector.
Doesn't matter what it looks like. You always have to calculate.
Okay.
Because
You have to
remember,
calculate anyways.
yeah, because remember we haven't drawn this to scale. So
Okay.
it doesn't matter much how it looks like. Right? You still need to calculate it.
Or you're still gonna get the angles.
Yes.
Cause I thought you'd have to like do something like where you're gonna move it 45 degrees west from north, like the blue line or something like that. But it just seems like you just drew it and then you're just gonna do calculations afterwards.
Now I'm going to calculate the angle. We have to determine the angles.
Okay, so carry on, sir.
Right. So you have to determine the angles. Right. In determining the angles, right, we have two angles. We have the one for VO from here to VO. Because remember, the 65 is a reference from north. So from north to here is 65. Right. So keep that in mind. And then VW is also a reference from north. That's the 45 degrees is a reference from north. Right. So that is to say, right, remember this, we used this small Cartesian plane. Right. And this angle is 45 degrees. Right, so from here to VW is 45 degrees, meaning that from here to here, what is that equal to?
45.
Exactly. So this is also 45 degrees. So now we have to determine this angle, right? So we are able to get this whole angle, right? We need to get the small angle here. Right, it's getting that small angle. If you look here, this angle and this one, right? They are alternating angles, right? Because this and this are parallel to each other. It means the angles formed here are alternating angles, right? So if you get this angle, you will inadvertently get that one, right? Now, how do you get this angle? We already know that from here to here is the 65, right? Meaning that 90 minus 65 should give us this angle. What is 90 minus 65?
25.
So if this is 25, it means that's 25, right? If this is 25, it means this whole angle is going to be 45 plus 25.
Gonna be 45 plus 25. 70.
Yes. Means this whole angle here is 70 degrees. Now the 70 degrees is between two known vectors, making it an included angle. Therefore, we are able to use the cosine rule to calculate VR. So now you name your vector diagram, call it AB, call it C. So that's C, that's A, and this here will be B. Right, so we are essentially looking for side A. Right, it's calculating side A using the cosine rule. This will be A squared is equal to B squared plus C squared minus 2BC times cos A. All right, so that's A squared is equal to side B is 45 kilometers per hour. So 45 squared plus side C is 220. So that's 220 squared minus 2 into 45 into 220 cos A. A is 70 degrees. Now what is A squared equal to? Just punch this in your calculators and give me exactly what you get. Do not round it off.
43653.00116.
116, right? And then, of course, to get A, simply use the square root on both sides.
Fuck.
So square root of this. Now, what is the square root of this? Right, did we all get the same thing here?
I think I was wrong,
It's
sir.
208.
Okay. Okay. So it's 208.
No, the final answer.
Or the final answer. All right.
Yes, it's 208.
Okay, so my question was, did everyone get the same thing here? Let's just make sure everything is correct here.
Yes, it's correct.
All right. So final answer is 208.
208,933.
933 kilometers per hour. All right. That's side A. We know side A represents VR, which is the resultant velocity. or the resulting velocity. Right. Now you have to calculate the direction. Right. The direction, right, will either be the direction or the angle thereof will either be from the y-axis or the x-axis. Right. Either way, we need to get this angle B, and then it's going to be up to you. If you reference your angle from the y-axis or x-axis, right? What I'm going to do is we are going to calculate this angle B, right? And then we are simply going to add the 25 degrees, thus referencing our angle from the x-axis. Right, so using the sine rule, right? So sine B divided by side B is equal to sine A divided by side A. Right. Now to get B is equal to arcsine of this. Arcsine of B sine A divided by side A. All right, so this is equal to, now you substitute arcsine of this. Side B is 45. 45 sine A, which is 70, divided by side A, which is the 208,933. And what do you get? What is B equal to? Angle B.
11.6.
11.
0.67.
677.
677 degrees. 11,677 degrees. Right, so remember, that is that angle. Right, this angle is neither reference from the x-axis or y-axis. Right, so we now are going to have to get the entire angle. Right, so from here to the x-axis. So we say the angle we just got plus the 25. Right, so let's call this
35.
theta. So the theta is equal to 11,677 plus the 25 degrees. And what is that equal to?
36.677.
36,677 degrees. Right, and now this angle is reference from the x-axis. Right, the x-axis of this quadrant is east, meaning that now we can say that therefore VR is 208,933 kilometers per hour. The direction, our angle is reference from the x-axis, so east 36,677 degrees north. Yeah.
Hello, sir.
Yes.
So just so I can just be clear about what you said just a few moments ago. Basically, your videos and your notes on Moodle are compulsory. They're not optional.
I would say if you want to pass the subject, yes. Because like I said, there is no way you can do this thing on your own. Because
this technique you just did is not in the textbook at all.
it is in the textbook, it's just not explained appropriately.
Oh,
It is in
because
the
what I read is not what you did. I read it, but then I got something different to what you. I read it, but then my technique that I interpreted was different from the one you just did right now.
yeah. Yeah, the textbook, it doesn't explain that well. It has good problems, but as far as explanations, it doesn't give good explanations. Right? That is where we come in as tutors.
Okay. Could it be possible, sir, where what you do, you just make like let's say a Word document, right? Or a PDF, and then you just put in all the links to your videos and even like QR codes, and then that is like the official link sheet to your videos, because Moodle is tricky. It doesn't work for everyone. So if you could just post that in the group once and for all, and then we know, okay, fine, we've got our textbook, and then we've got like your kind of textbook in inverted commas, which is all your videos and all your materials.
So the thing with that is, as much as because I have thought about it before, it's just that yeah, I can't do it at the moment. It's gonna be too much work. And the thing is, all of this is essentially my intellectual property, right? So for me to do that for not linked students and not be compensated for it, it's going to be a problem, because even
Yes, sir.
even the stuff I put on Moodle, right, it is open to everyone. So even other tutors, other lecturers have access to it, right? So
Yes, sir.
as much as I want to help as much as possible, right, but some of the stuff I cannot do because I'm not compensated for.
Yes, sir.
Yes.
Yes.
Like if you can even, like before we started, I actually went to your YouTube channel. I think it was like 2 months ago, yes, and I went through it. It was a bit confusing for me, sir. So if you can maybe make more playlists, like say you put all of your info, engineering science, all that videos into one, not the live sessions, but the what you call it, the actual videos where you explain and give class, because I found it tricky to navigate through your channel and find the correct topics and all of that. So
Yeah.
I think that would also benefit us.
Um. Look here. I'll go to the channel just now. I just want to show you how easy it is to navigate my channel. All right. So you go to the channel. Go to. In fact, let me try doing this from your perspective. All right. So you search the underscore nated god. I'm a nated underscore god. Right. You see my channel. You go straight to the playlist. Here, my playlist here. All right. Now, for instance, we are going to look at dynamics. There's a whole playlist for dynamics here. Right. For engineering science and for. Right. Now I'm still going to add more videos there, but there's an entire playlist just for dynamics only. Right. Similarly with heat transfer. I mean, not heat transfer, heat. Right. I'm still going to upload more videos, but there is a playlist for heat only. Right. Same thing with stress and strain. Right. There's a whole playlist just for stress and strain. Right.
And
Then hydraulic
projectiles, sir, where can we find projectiles? Because
projectiles.
that's what I was looking for. Yes, sir.
Right. Now projectiles doesn't have a playlist. Projectiles is in the engineering science N4, not link group. Right there, projectiles. Projectile motions, projectile motion teams meeting, engineering science N4. That's the only video I have on projectiles for now, anyway.
Excuse me, sir, while on the topic of your channel, I couldn't find anything on angular motions. Do you have anything on angular motions?
Nah, nothing on angular motion, but I will have videos for you guys this block on angular motion.
Hello, sir.
Yes.
So your material comes from the kindness of your heart, right? And then
Yeah.
the official Northlink material has very how can I say mediocre explanations, and also it has errors here and there. So then what's the official material that's perfect?
There isn't one that is perfect. Also, it's not necessarily Northlink material. It's just the textbooks that we are using there. Right. The textbook that you're using for engineering science, that's probably the best one that I've seen. Right. Even though
That you've
it
seen,
is a,
yet you just said that it is far from perfect.
yes, very far from perfect. You are not going to find perfect textbooks at college level. Right.
At college level.
Yes, you are not going to find perfect textbooks because if you look at the authors, right, the authors um, are lecturers, right? Now you find that the lecturers that are authors for the book are not even teaching the subject, right? And that is not our problem. That is a DHET problem.
It's not
Right?
our problem.
Yes, as a college, we have no control over that. We have no control over who authors the textbooks. Right? But
Oh,
my
DHT has control over that.
DHET, yeah, they they're the ones who do the vetting. They're the ones who select whoever's going to author your textbooks. Right? But my point is, unlike with textbooks that we use at varsity level, that are written by
Yes.
professors, doctors, right? These ones are written by people that sometimes do not even teach the subject.
Do not
Right?
even?
Do
You
do not
can't,
even
sir?
teach
Please
the
repeat. You
subject.
said do not
Do
even
not
teach
even
the
teach
subject.
the subject. Yes.
Okay.
That is why you see so many flaws in the textbook.
Oh, are they perhaps people who are teaching electrical or something, or not? Let me not say electrical, but like maybe someone who's teaching like biology or something like that.
So I cannot be specific, right? But what I'm saying is
He cannot be.
specific as to
Yes.
uh, the subject they are teaching, right? Some of them are even retired, right?
Mm,
That's my point. That
okay.
Northlink is not to blame, not necessarily, because what we can do
Okay.
is select a textbook from the ones that exist.
From the ones that exist.
Yeah,
Okay.
of the ones that
I
exist,
see.
this is the best one for engineering science. Right?
Okay.
You're going to see a lot of this, even in N6. When you get to N6, um, there's a textbook by Sparrow Consulting, very bad, very, very, very bad textbook. And then there's one by Pete Dutoit. Now that one is much better. Pete Dutoit, if I'm being honest,
Mm.
he's the only one who does it for me. Even for strength of materials, the best textbook that I've identified was written by him. For fluid mechanics, same story.
Oh. So have you applied to the college so that they can compensate you for your work in compiling a better curriculum for us?
So as far as curriculum, We don't do it at this level. DHEC does that.
Okay, but I'm saying there's a lot of, like, as you say, like flaws, right? So for
Yeah.
you to correct the flaws, that means a lot of work on your side, and the college needs to compensate you for it. So have you spoken to them?
It's not a conversation that can even be had because the door for it doesn't exist. It's one thing to have the door open, or it's one thing to have a door that is closed, right? A closed door,
Mm,
one that can be open, right? At the moment, the door does not exist.
oh, I see. I just want to work out where the buck stops when it comes to the quality of a material, because
Yeah,
you're saying it stops at DHET, but then they're very far away. So in terms of my end, I hand over school fees to Northlink, so I expect them then to make a plan.
yeah.
So it's
Well,
just a bit odd that.
well,
Hello?
the way that Notlink makes a plan is by hiring us, your tutors, right? And then we
Oh, I see.
guide you through the content, right? What I was saying is, as far as doing what one of your fellow students suggested, right? Based on that suggestion, I cannot do it, right? I can't do it because it's not work I'd be compensated for, right? Hence, I use Moodle.
Oh, okay.
Now,
That makes much more sense, sir.
like for instance, if the institute can say, Mr. Mteto, please do high quality videos for us for engineering science. We will pay you this much, for instance. Yeah, I'd be open to that. I'd be open to that conversation, right? Because it is my intellectual property, and for me to do that, knowing very well that it's not only you guys that is going to have access to it, but the rest of the lecturers as well.
Hi, sir. I have a
Mm.
question
Yes.
on that. What on that? Do you have private lessons?
Nah, I don't do private lessons.
Okay,
Don't have time for them
all right.
because if I figured, because I've thought about it, but if you're paying me for your time, then I have to give you the time you are paying for, and that time I do not have. So to
Oh, got you.
to for me not to be unfair to you, right? Have you pay me all this money, and then sometimes I'm not available. You see what I'm saying? It's gonna be a problem, right? I don't want to have to compromise, right? You as someone who's paying me, or the students at Northlink College, right? So I'm too committed at Northlink right now to have private lessons, right? So I don't do private lessons. Also, it's a bit of a problem because I'd have to probably Northlink would see that as a conflict of interest, probably. So to avoid having to go through that red tape as well, right? I don't do it. Do you get my point?
I got you, sir.
Yeah.
Please upload more videos then.
Yeah, I'll upload more videos. As from this week, I'll be uploading a lot of content for all my subjects.
Sorry, sir.
Yes.
Our our HOD, Mr. Gulumela, he said that we must be well aware that online, right, is self-study, right? There's a
That is
very
correct.
big emphasis on
Yeah.
our own efforts, right?
Yes.
Very big emphasis, right? But
Mhm.
then was you also aware that the tools we've been given for self-study are very flawed?
Yeah, we are all aware of that. We are all aware of that. Also, eh, yeah, it's I hear you, and we are aware